Over 2 billion tons of waste are produced by humans every year, and glass makes up nearly 20% of that. The crazy part, a single glass bottle can sit in a landfill for over 1,000,000 years without breaking down. But here's the good news. Glass can be recycled forever without losing quality. So how does that process actually work? How do messy, broken shards get reborn into clean, shiny bottles? Let's step inside one of the world's largest glass recycling factory, where hundreds of tons of glass are brought back to life every single day, and uncover the secrets behind the unbelievable journey of the most sustainable material on Earth. Let's get started. Used glass bottle collection. To recycle glass, the first requirement is a steady supply of used bottles. In daily life, empty beer or soda bottles are often tossed together with regular household trash, which makes sorting for recycling costly and complicated. But in many European countries, a system has been designed to handle this problem right at the source. Glass bottle return machines are installed across city streets. Consumers simply place an empty bottle into the machine, which scans it, sorts it, and gives back a small refund, usually around 10 to 20 cents per bottle. That means a freshly finished beer bottle, instead of ending up as waste, instantly turns into a valuable asset with cash value. This approach motivates people to collect bottles on their own, while also providing factories with a stream of glass that's already pre-sorted, clean, and far more consistent. Europe seems to have it all figured out, but what about the US? Do we have systems this advanced here too? Drop a comment and let me know what you think. When the reverse vending machines are full, collection companies send out specialized trucks to pick up the bottles. Large plastic bins, each holding thousands of empty glass bottles, are loaded onto the trucks with forklifts. A single full-size truck can carry between 20,000 and 30,000 bottles in one trip, equal to about 10 to 12 tons of material. Trucks loaded with glass bottles quickly make their way from supermarkets and collection points to the recycling plant, each one carrying tens of thousands of empties packed tightly in bins. When they arrive, the drivers back up to a massive storage bay and release the load, sending a cascade of bottles tumbling down. In just minutes, the ground fills with colorful mountains of glass that sparkle, greens, browns, and clears stacked together. These piles aren't just waste, they're the starting point of the entire recycling chain, a steady supply of raw material waiting to be cleaned and crushed. Glass recycle processing. To kick off the recycling process, massive loaders drive up to the towering piles of waste glass. They scoop up huge loads with their buckets and carry them across the yard. With a thunderous crash, the glass is finally dumped into the plant's feed hopper, sending a cascade of shards down the steel chute. Instantly, the steel conveyor starts moving, carrying the stream of glass mixed with dirt and sand deep into the facility. The first stop is the vibrating screen, where powerful shakes separate out dust, grit, and tiny particles. After this stage, the glass is much cleaner, but larger contaminants that machines can't easily detect still remain. Along the conveyor, workers stand ready, carefully pulling out paper, plastics, and anything else that doesn't belong. This blend of mechanical screening and human hands produces a cleaner batch of material ready for the next step in the recycling journey. Do you know what's still hiding in that pile of broken glass? The bottle caps. Luckily, most of them are made of metal, which means they can be pulled out easily with a high-powered magnetic separator. The principle is simple. The strong magnetic field grabs the bits of steel while the glass keeps moving down the conveyor. Thanks to this step, the glass is now about 80% clean.
And one step closer to its journey of rebirth. Once most of the contaminants have been removed, the glass moves on to the next crucial step, being ground into cullet. The larger pieces are fed into a hammer mill, A massive machine with high-speed rotating hammers that smash the glass over and over until only tiny fragments remain. Any pieces that are still too big are automatically detected and sent back through the mill until they reach the right size. This makes sure the entire glass stream is uniform, with no stragglers slipping through. The process creates cullet. Fine sparkling glass, particles that look almost like man-made sand. Because it's broken down so small, cullet melts much faster in the furnace, saving up to 40% of the energy compared to using raw materials like sand or limestone. After that, the cullet is carried to a powerful suction system where it's blasted with a strong stream of air. This airflow strips away and blows off any leftover label fragments, leaving the glass even cleaner. Finally, the cullet moves into the optical sorting system, the most precise step in the entire process. As the glass cascades down like a shimmering waterfall, laser sensors continuously scan each tiny fragment to detect its color and composition. The moment brown glass, green glass, or even a stray ceramic shard is identified, the system instantly fires a precise puff of air, shooting it into a separate stream. The speed is almost unbelievable. Tens of thousands of pieces are processed every single minute. This ensures that the cullet is sorted with perfect accuracy by color, because even the slightest mix of the wrong shade would ruin the quality of recycled glass. Once the cullet has been sorted, it continues moving along the conveyor belt. The tiny glass particles are directed into separate storage areas, each divided by color. There they gradually pile up into massive stockpiles, waiting to be transformed into brand new glass bottles. Glass bottle processing. After being sorted and ground down, cullet can't go straight into the furnace on its own. It needs to be blended with raw ingredients first. The mix starts with pure silica sand, the key element that gives glass its clarity. Then comes soda ash, or sodium carbonate, which lowers the melting temperature and saves energy across the entire process. Limestone is added as well, strengthening the glass and making it more stable once formed. In some formulas, manufacturers also include dolomite, alumina, or metal oxides to adjust color and properties. The most important part, though, is still the cullet, which can make up anywhere from 20 to 70% of the batch, allowing the melt to flow faster and cutting energy use by up to 40% compared to brand new raw materials. In fact, adding just 10% more cullet can reduce energy consumption by about 3% and significantly cut CO2 emissions. With the predetermined formulas from the factories, the mixture is mixed evenly and ready for the melting process. The blended mix is then fed into a massive gas furnace where temperatures reach about 1250 degrees Celsius, even hotter than molten lava from a volcano. Technicians carefully monitor the entire process and pour the mixture into special crucibles inside the facility. Workers must wear fireproof suits and heavy gloves, as the surrounding heat, nearly 3,000 degrees, is almost unbearable. Once the ingredients stabilize, the mouth of each crucible is sealed to maintain the extreme heat and control the melting process. After 24 hours, the mixture is no longer sand. It begins to flow thick like lava. The brilliant glow at the bottom of the furnace is liquid glass, a dense, shining mass that has reached the perfect temperature and viscosity for the next step. For the next 5 hours, the glass remains in its molten state, allowing any remaining gases to escape and ensuring the highest purity in the final material. To shape glass, a mold is required, which makes mold creation the next step in the process. Engineers use advanced CAD software to design the mold with high precision, carefully controlling every line, dimension, and thickness to meet technical standards. From this digital design, molds are manufactured from cast iron or alloy steel, capable of withstanding temperatures of up to about 1400 degrees. These molds are then prepared to receive the molten glass and form it from the inside. Once the molds are fully completed, they are carefully installed into the double-blow production line, one of the most widely used and reliable methods for shaping hollow glass products, such as soft drink bottles, food jars, and pharmaceutical containers. The forming process begins by dropping molten glass, known as gobs, into the initial blank mold. These gobs are cut from a continuous stream of liquid glass, reaching temperatures of around 1011 degrees Celsius, and have the perfect viscosity for smooth and consistent shaping. Inside the preliminary mold, a jet of compressed air is blown in from above, pushing the hot glass outward against the mold walls. This forms the initial shape known as a parison, a hollow bubble-like structure with a narrow neck. Still glowing with intense heat, the glass is gently transferred to the final mold, which sits just a few inches away on the same production line.
Here, a second burst of compressed air is shot directly into the center of the parison, stretching the softened glass outward until it presses tightly against every contour and detail of the mold's inner cavity. In just a matter of seconds, the full shape of the bottle takes form. It may look quick and effortless from the outside, but behind the scenes, every valve and sensor in the system is timed with incredible accuracy, synchronized down to 1,000th of a second. This extreme level of control is what makes it possible to manufacture hundreds of thousands of bottles per day, each one nearly identical and flawless, as if they all came from a single perfect mold just released from the oven. The glass bottles radiate a deep red heat, their surfaces shimmering in the dark as if they were glowing metal rods. Robotic arms then move in with seamless, programmed precision, gliding effortlessly into place. Each bottle is lifted with care and set down onto the conveyor belt. The whole scene unfolds in calm silence, perfectly synchronized without a hint of haste. The conveyor belt slowly guides the newly formed bottles, their bases still glowing with heat, toward the cooling area. They travel through a long yellow tunnel, where the temperature lowers little by little, giving the glass time to settle safely without breaking. This careful cooling stage takes its time. It may last several minutes, and sometimes even stretch to tens of minutes before it's done. As the process moves forward, the cooled glass bottles reach the inspection stage. Here, an array of optical sensors and high-speed cameras examines each one in real time. Every detail is checked, and the moment a defect appears, whether it's a crack, bubble, scratch, or even a tiny warp, the system immediately flags it and pulls the bottle off the line. The next stage focuses on a close examination of the bottle's mouth. Each bottle is rotated with precision by an automated system, while optical sensors and mechanical probes team up to detect flaws. Whether it's a chipped edge, a fine crack, or the smallest deviation in dimension, only bottles that pass this strict check are allowed to move forward. After clearing all inspections, the glass bottles are carried to the palletizing section, where robotic systems take charge. Designed for accuracy and uniformity, these machines organize thousands of bottles with ease. A clamp mechanism with suction cups lowers, grips a full row, and sets it carefully onto the pallet layer. To protect against impact during handling and shipping, a sheet is placed between each layer. When the stack is finished, an automated wrapper secures the pallet in film and tags it with a code that corresponds to its production batch. Finally, the glass pallets are moved into storage, neatly stacked and ready for shipment. From there, they'll travel across the globe, soon to become sparkling bottles filled to the brim and ready to serve in every corner of daily life. Coca-Cola glass bottling line. And of course, glass bottles are made to hold drinks, and let's be honest, just about everyone has had a Coca-Cola at least once in their life.
These glass bottles are filled with the world's most iconic soda, but before they hit the shelves, they go through a tightly controlled bottling process. First, each bottle is thoroughly cleaned using high-pressure hot water and steam to eliminate any dust or bacteria. Then they move down a high-speed conveyor to the filling station, where automated nozzles fill each one with Coca-Cola down to the exact milliliter. At the same time, CO2 gas is injected to lock in that signature fizz right after filling. The bottles head straight to the capping station, where crown caps are pressed on with precision machines. Each cap undergoes a detailed inspection for tightness using high-precision sensors integrated into the capping line. This ensures that every bottle is perfectly sealed, preventing even the smallest leaks before the product is packed and shipped out. Then, each bottle passes through a high-speed camera system that checks for cracks, overfilling, or misapplied labels. The Coca-Cola bottles continue gliding smoothly along the conveyor belt, lined up in perfect formation like a programmed assembly, moving through each stage of the line with steady, precise rhythm as they reach the water spray station. A high-pressure jet of cold water is aimed directly at the neck of each bottle. Finally, the perfectly sealed Coca-Cola bottles are packed into cartons, loaded onto pallets, and moved into cold storage, ready to be shipped to millions of stores worldwide, from small roadside shops to luxury hotels. Conclusion. And just like that, the glass's journey of rebirth comes to an end, rising from broken shards to become something shiny, pure, and full of value once again. Recycling glass into brand new bottles isn't just a win for the environment. It's a reminder of the magic behind modern technology. We hope this video inspires you to make glass recycling a habit in your own life. Drop a comment below and let us know what you think. And don't forget to like, share, and subscribe to keep exploring more fascinating industrial journeys with us.